The future of transportation is going to have many modes. Certainly, micromobility, cars in many forms, shuttle buses. But what about air travel, especially that niche between traditional air travel and ground transportation? And that's where air taxis come in. They're going to help us address the needs that are related both to the ground and to the air. And recently, at the Detroit Auto Show, I met someone that is starting a vertical takeoff and landing aircraft company that's going to give us transportation between cities, airports, and the suburbs. His name is John Rimonelli. He's the CEO and founder of Aerospace Experience Technologies, ASX, and I am sure that John can help us understand exactly where air taxis and urban air vehicles fit into the whole transportation scheme. John, welcome to the Future Car Podcast.
Edward, it's a pleasure to be here, and thanks for having me on.
So let's start at the top. Tell us, what are air taxis or urban air vehicles? Why do we need them? How do they fit in to the whole transportation scheme?
Yeah, well, it's a great question, Edward. I mean, if you can sort of use a big urban center like New York or Chicago as sort of an example for how we've taken a finite amount of real estate and it expanded skywards because we just ran out of real estate on the ground floor, right? So if you think of it along those lines, our roadways are at capacity. The very technology that we've used to democratize mobility for the mass traveling public is now choking cities, airports, and suburbs with congestion and traffic, which is spewing emissions into the national airspace system. We're wasting time, we're wasting money. So when you think about, the fact that we are at capacity on the roadways, we need to do something different. And we need to start to look skywards and elevate traffic. So that's the main driver, right, behind this global industry effort to elevate traffic is we're running out of room on the roads. If not, we have run out of room in many cities.
So why not just helicopters? You've got your
Yeah.
your traditional aircraft, your airliners leaving and coming and going from airports. We've got all this transportation on the ground. Why not just take a helicopter from the
Well, that's a
city
good question, Edward. I mean, helicopters are certainly, the state of the art. They're loud, they're expensive to maintain, they're expensive to operate. Probably the biggest problem is noise for urban centers. I mean, many urban centers around the country have banned helicopter use. For instance, I mean, in the 60s and 70s, we saw a lot more helicopter pads in urban centers, but as people started to complain about the noise, they shut those helipads down, right? So between noise and the cost of acquiring the skills required and the maintenance, it's just prohibitive.
So noise, skills, and cost.
Yeah.
So we're looking at an aircraft that's easy to pilot, probably be a lot less costly for that ride from the city to the airport. How does it compare from a cost standpoint to, say, a helicopter or taking an Uber on the ground? Relative cost between the three.
So we like to benchmark the Eurocopter 130 as an equivalent vehicle with equivalent payload capacity. It's up to around 7 passengers, almost a few thousand pounds of payload. Just a dry rate on the machine's about $1,400 an hour. We are currently, the math, not including all the inflation that's taking place, we're going to revise our numbers, but we're in the $600 to $700 an hour range, where they're, $1,300 to $1,400 an hour, and that's dry. That's maintenance, repair, overhaul, operations, insurance. So we, we're going to be about half the price of a Eurocopter to operate. Now, assuming that we can get our supply chain back in order and we don't have distractions like my cell phone. But we're half the noise signature on our machine is about 70 decibels at about 100 feet above your head, whereas a helicopter is going to be in the neighborhood of 100 decibels at about 100 feet above your head. So considerably noisier, and an order of magnitude lower in cost.
If you were to take the classic ride is from downtown New York City to LaGuardia or Kennedy, something like that. What's the cost of a helicopter for that ride, roughly, more or less? And what do you think it'll be for an urban air taxi, your typical urban air taxi?
Well, so the target for us is to be equivalent in cost to a ride share, an Uber Black Ride. We're looking at about anywhere from you know $75 to $100 for a ride to the airport. I mean, I haven't checked that fare in a while, but it would be equivalent in cost to an Uber Black Ride, with in essentially about 15 minutes as opposed to about 45.
If you're lucky, 45, I would have
Yeah,
imagined.
if you're
Could
lucky,
be
it's
hours. That's
Yes.
probably the other thing that's good is that it's predictable. You know roughly how long it's going to take you to go through the air in a straight line from downtown New York to the airport, where you never know what's going to happen with traffic. So you could probably better utilize your time as well.
So right now you're looking at about a 27-minute ride. So you know, at this time of day, it's about 10 miles. So you'd be looking at about at least half the time.
So there's a lot of air taxi companies out there. Airbus, Joby Aviation, several of them. How is your air taxi? How's it different? How's it compared?
Well, we don't. So, from an air taxi standpoint, that is a concept of operation for electric VTOL. It's not the only concept of operation. And what we did is we designed an air vehicle that is flexible to do the job of moving cargo, medevac, emergency responders, as well as passengers. So we really wanted to build a vehicle that was flexible, that could be repurposed on demand to do a variety of jobs. Our first job to do is not passenger mobility; it's actually defense and cargo. I'm actually working, with the U.S. Mail Service right now to look at how we can improve the distribution of mail from their hubs to their regional stations. So cargo is a massive opportunity, and a big part of our mission is to elevate that cargo off the road, and down the line we've got an opportunity for passenger mobility, and we certainly are going to go down that road. But right now our primary mission is defense and cargo mobility.
As I mentioned earlier, I met you at the Detroit Auto Show, and first thing you see this big wing, the propellers. Wow, at an auto show, you don't really expect it. But what was really unique about what I saw was that there's a pod that can move in underneath, so it gives you somewhat of a seamless connection between what's happening on the ground and in the air. So this pod seems to be unique to what you're doing. Are there other pod aircraft out there? And tell us about the pod and really
Yeah. So
how
this
it
boils
makes what
down to
you're
the
doing
flexibility
unique.
of the machine. Having built a number of these aircraft, one of the things that bugs me the most is, when they're purpose built and you want to repurpose it, you really have to reconfigure the vehicle to do that. And so what we did is we designed a hot swappable payload system where we can plug and play a new container or a new pod to do a different job. And that new pod could contain a fresh set of batteries to basically eliminate downtime on the ground for, recharging. We do have a ground vehicle, an autonomous ground vehicle that does the job of plugging and playing the pod in a closed circuit environment, be it an airport, a factory, a distribution center, a military base. These containers, these pods can weigh as much as 2,000 pounds. So you need, hardware to move, plug and play that container into the aircraft. So I think that's it's unique in that we have a highly flexible system, whereas 99% of our competitors do not. There are certainly trade-offs associated to having this bit of flexibility, this modularity, but so it's not really optimized aerodynamically per se, but it's optimized for mobility, right? It's like I've got a seaplane, it's great, it lands on the water, it lands on a runway, it flies, I could pull up on a beach with it, but it's not the greatest airplane, it's not the most aerodynamic, but it does the job well enough to get the job done. So we realized, there was going to be trade-offs in the flexibility, but we figured that it would be more optimized for mobility because at the end of the day, we want to be able to blend with these other modes. So we've talked to different car companies about doing first and last mile operations where they build an autonomous vehicle platform. We can then place our pod or container on that autonomous vehicle or even, piloted vehicle and go on a first and last mile delivery. So that is a pretty distinct difference. And it's all about this concept of seamlessly moving product from air to ground. Since we have an opportunity to sort of reinvent and reimagine mobility, like what would we do different? And if we could have a symbiotic relationship with a ground vehicle, we can do a lot more, a lot faster, a lot more efficiently.
So the idea would be, in what you're describing here, is I could get into a ground vehicle that's basically your pod on wheels, and then that would take me to your, I guess you'd call it a port, where your
vertiport, yeah.
air vehicle is located. And what do you actually call it? You
So
don't call it
the industry refers to them as vertiports. I mean, some people call them
Vertiports.
skyports. It's a location where we can land, unload, reload, and depart, right? Which right now is, in the United States, there are some 5,000 small community airports that we intend to leverage. They got power, they got infrastructure, they got cheap real estate, which we like. But in cities, we will see vertiports that are specifically designed to meet our requirements.
So you could get into the pod on the ground, much like you'd get into any car, and ultimately then it would drop it underneath your vehicle. It'd be interface quickly, automatically into the actual air vehicle, and then
Yeah.
zip you off to the airport or wherever. Or
Yeah.
could be cargo, could be anything.
So the target is a 2-minute changeover from one container to the next. And conceivably, we could in fact do a first mile pickup to a vertiport and take a passenger or a cargo load on the middle mile using the Sigma 6 aircraft, and then the final mile. Right now, we are very focused on between cities, airports, and suburbs, doing the jobs of, moving cargo on the air side. As we develop more partnerships on the ground, which they seem to be very, very interested in this concept of operation, somebody else would do the first last mile business.
When do you think you'll actually be able to get a ride commercially available? Get a ride, or let's just say cargo. You said you'll start with cargo. When do you think you'll have a cargo service in Detroit that people can utilize?
Well, I think right now our timing is trending towards 25, 26 to begin sort of trials. We've sort of, we were supposed to be at this point 2 years ago. When COVID hit, it really made the job of building this machine very difficult. We still got it done. It took us a year longer as a result of COVID, but so our timelines have been pushed back, and so we're hopeful that 26 is when we'll really start seeing it. But I think though other guys like Joby and Joby's doing a great job right now. They're mowing the lawn for us regulatory wise and getting people adjusted to this reality. It is coming.
Well, sometimes it's better to be the second or the third one and let somebody else take care of, like you said, making sure all the regulations are there and that type of thing.
Yeah, absolutely.
You talk about democratizing air mobility for the masses. Now, what exactly does that mean?
Well, look, it means making these things accessible to people. One of the things that really inspired me to get in this business is, I had the freedom to fly airplanes at will, 360 degrees, and it really is liberating, right? Because, instead of sitting in traffic, you're staring down on it, and it's always bugged me that, ordinary, Americans who, are working 9 to 5 jobs and making middle class wages can't afford to participate in this level of mobility, and that's always bothered me. It just felt like it's very unfair. And Detroit has got this great history of doing that business of democratizing travel, building cars that are affordable for people. So it's always been sort of my objective to make aircraft systems very much like we make automobiles, at scale, using the same production processes, same techniques. And when you think about the requirements of a ground vehicle or an aircraft, there's a lot of overlap, right? And we've taken sort of a ground up approach to designing and building our machine. So it's all about employing automotive electric vehicle architectures, mass production techniques, and producing these things at scale so they can be affordable for regular people, because it's just not interesting to me if there isn't that opportunity to improve the quality of life for people, right? I'm not interested in working for rich people. I'd rather work for, ordinary people, right? Regular people, the masses, right? So that would be my long-term objective, yeah.
Transportation is key to so many things, to education, to accessibility, to the things that you need to live your life day to day. Do you envision at some point in the future that it could be a school bus or something like that?
I got to tell you, I had a school bus drivers come to us during the show, and they're like, "Man, this would be fantastic if we could move children this way, because they sit in congestion all day long. That's all they do, and these kids are wasting hours of their days sitting in traffic." And the main thing is, if we can elevate some of this unnecessary traffic, this cargo, for instance, if we can move that other traffic off the roadways, we might be able to lessen the load on the road, so these school buses wouldn't have as much of a problem getting kids to and from school. I mean, that's really the problem. We just have too many cars on the road, and the roads are, they're limited in how big they can get, and they're expensive to add more. So it's really just about lightening the load on the road and elevating traffic, starting with cargo. I mean, there's a lot of cargo we can take off the road.
Now, in order to do this, you'd have to cooperate with the other urban air vehicle companies, I would imagine. So you all
Yep.
accept the same protocol and methodology to
Yeah,
communicate.
it's low cost is the good news. Is a low cost system. It already exists. It's like technology readiness level of like 9, 10. Let's call it a 9. And it already exists. There are vehicle and there are hardware manufacturers that already have this stuff in stock, no waiting. On the ground, it's been a bit of a challenge to deploy it, because the government has pretty much made communities responsible for upgrading their roadways with wireless infrastructure, and everybody complains about not having enough money for the roads. Well, they don't have enough money for the roads. They don't have enough money for wireless infrastructure. But now that we make it a dual purpose system, right? It's a dual use technology. It's now infrastructure that the government and local communities can now see the value in. It's not just a single purpose, infrastructure. It's not just for cars. It's for aircraft and ground vehicles.
Well, leveraging what's going on the ground for connected vehicles makes a lot of sense. Just take the protocols or whatever it might be and take it into the air. but it is three dimensions and not two. I think about those Star Wars movies where you see the perfectly aligned lines of cars or air, whatever you want to call them, AirPods or whatever, just flying all perfectly aligned. How do you, when you bring that third dimension in, it must create some new problems that aren't
Yeah.
addressed on the
Yeah.
ground. Are you
So,
addressing those somehow?
so the short range wireless communication system basically allows a vehicle to establish, separation standards, right? You can't get any closer to me than X, Y, and Z, right? So when you're platooning vehicles in and out of an urban center, they can be, you know, sort of caravanned in with a precision, right? So there's no, maintaining. It's almost like you have, we have adaptive cruise control on the ground. It's like having adaptive cruise control in the air, right? When my vehicle and other vehicles are able to compete with each other. So that is a big, feature, an important feature of the short range wireless. If we've demonstrated platooning, we can sequence and separate traffic autonomously, and that's what you're going to need if we're going to see a high volume and a high density of these vehicles going in and out of urban centers.
So do you think, you mentioned platooning, so do you think it will be somewhat like that? Like here's a corridor or maybe like a tube in the air, and when you're going one direction it's this way, when the other direction it's a different tube, shall we say, or
Yeah.
corridor they have to fly through?
Yeah, so you essentially have levels of mobility. So you have, from 0 to 400 feet is really where the small unmanned systems traffic will operate. And at 100 feet, it'll be low speed. 200 feet, it'll be slightly higher speed. 3 to 400 feet will be your high speed lane. And then you'll have this, the larger electric VTOLs and helicopters transitioning through that space. So they are going to segment the airspace. This low altitude aircraft infrastructure, if you will. So it's all heading in the right direction. It's just the government doesn't really want to, say this is the standard, this is what we're going to do. They kind of want industry to do that. They want industry to sort of decide what the final infrastructure should look like. And they're finally now picking up on the approach that we've been proposing because it's already in existence from a technology readiness level. So that piece is actually quite it's ready.
Is there a lot of cooperation and a lot of communication between the different manufacturers of urban air vehicles to move this
There
forward?
isn't. I'd like there to be. Through the Vertical Flight Society does a great job of serving as an industry consortium to advance mobility and create working groups to solve problems. But I think in order for this to really be successful, that we need to build a standard class of vehicles, with and increase the volume of production of those components to the point where we're able to get high reliability data to support safety, right? Because that's a number one priority, right? Is making sure that people in the air and on the ground are safe. And whenever we can standardize hardware, software, technology, the better, right? Because there's less opportunity for anomalies, right? When you have standards in the architecture, in my view.
Yeah, nobody likes anomalies. And if you were going to try and get the ordinary consumer, let's just call them that, do you think when this service is finally available, there's going to be some hesitancy to jump into an urban air vehicle?
Surprisingly, a lot of people are very, anxious to get in these things. There's
The
still
early
that human,
adopters.
there's yeah, the early adopters. I mean, there's certainly, I think the human nature is that we all like the idea of flying. A lot of people do. And I get asked all the time, can I come down and take a ride? No, not yet. not yet. But when my team says it's safe, then I can fly. But until then, I'm grounded like the rest of you.
I guess if we see you flying, then we know it's got to be safe, and that probably gets us to the point where we say, "Well, if he's
I
flying,
mean,
then
anybody.
I'll give it a try."
Well, the distributed electric propulsion adds that additional level of redundancy, right? That was the whole concept behind distributed electric propulsion. We distribute the load across a plurality of rotors and motors, so that if one fails or two fails, we can arrest a descent and land safely.
Can you tell us a little bit about the range and the amount of cargo you can carry, and how those interrelate to what your vehicle is going to be able to do?
Well, so purely electric with 2,000 pounds with let's call it future battery. By the time we're certified, we're looking at about 65 miles with 2,000 pounds and about 150 miles pure electric with 1,000 pounds. And if we go hybrid, we can go around 450 miles with 2,000 pounds, and we can do about 700 to 900 miles with 1,000 pounds. So, the range really is going to be determined by how much you want to move and what propulsion system, what source of energy you have on board.
I suppose since you have a pod, depending on what's in the pod, if it's a defense application or a first responder or whatever it might be, will impact that depending on the weight of the pod and what's inside of it.
Yeah.
Transforming, connecting it up in just a couple of minutes, I would imagine, especially if you're going to start to work with automotive companies or maybe even other urban air vehicle companies, you have to standardize that interface some way. Is there steps to doing that?
So the vision is for a multimodal transportation system that standardizes a container. It standardizes the interface to the aircraft, the container, and the ground vehicle. There's one automotive company that we are working with actively at this moment to develop an interface. We're not speaking publicly about it just yet, but we are working hand in hand with another automotive OEM to develop that standard interface.
Do you think over time that there'll be other, I don't know if you want to call them pod type air vehicles like this? Mm-hmm. It'll just become somewhat commonplace rather than purpose built. I guess that's a trade-off, right? This pod approach versus a purpose built.
So if we were able to create the ultimate mobility system, right, we would have a container that could be driven, it could be flown, it could be put on a rail car, it could be put on a marine vessel. So that way we maximize the opportunity for mobility, right? So, and there's only going to be so much space on the ground for ground vehicles, right? And there's going to, we have a lot more capacity in the air to manage traffic than we do on the ground. But if we had the ability to harmonize mobility and, truly share mobility between air and ground vehicles and have a variety of OEMs participate in the aircraft, in the container, in the ground vehicle, you end up with a whole new system for transportation that is ultimately more efficient, especially now with batteries being scarce. Now we can share energy between ground and air transport systems by virtue of the container, which is, I think that problem's not going to go away. I mean, there's only a finite amount of resources in the world that are available. And I think if we're going to truly share mobility, that we've got to, really grow this concept of multimodal transportation. And that's what we're hoping to demonstrate with our machine and invite other industry players to participate.
So tell me, let's look 10 years into the future, and then let's take a big step after that, and let's go to, say, the year 2050, when all this autonomous cars, urban air vehicles, autonomous mode, pilot assisted modes, whatever it might be, micromobility. The cities have embraced it, and the cities are redesigned to take advantage of this. What do you think we'll see in 10 years? And then what do you think we'll see in, let's call it 30 years?
Well, in 10 years, you're going to see, I would say, hockey stick growth in urban air mobility. We're going to see it in all major cities around the country, ferrying people from the suburbs to the cities to the big airports. That is going to be, really, shall I say, taking off. I mean, we see a level of maturity in that business. We'll start to see a lot of autonomy. If in fact, we should be autonomous by then in the air. From our side, we'd love to see autonomy on the ground, moving our containers from the vertiport to its first or last mile destination. And, so I'd say within 10 years, we're going to really see this thing, the business of urban air mobility in flight. I mean, that's very exciting. I think we'll see that within 3 to 4 years, quite frankly. But it'll really be maturing by 2030, 2032. 2040, we're going to be $1 trillion, industry worldwide. We're going to see more, what I would say, less air taxi service and more autonomy for individual and personal air mobility by 2040. But big aircraft moving cargo, are still going to be a thing.
It's almost like you're going to need a three-dimensional Waze. And depending on what you want, lowest cost, least amount of time, best sustainability, least impact, you could pick what you want. Are you thinking about that? Do you think there's people out there working on the 3D Waze of the future?
100%. It's already being done. 100%. Well, it's just another transportation option. If you look at your mobile app, you can do walk, bike, drive. Another option will be fly.
Right, and it'll be a straight line from A to B.
It may be a straight line, depending on, there may be an
little dog leg in there or something.
There may be a fire that's, clouding the air, if you will, and, putting debris into the air, so they may need to reroute traffic. But it's all about that option. It's a transportation option, and we're going to have it. It's coming.
John, thank you so much. Thank you for joining us and for taking the time with us.
Pleasure, Edward. Thank you so much. And looking forward to our next chat.